Okay. At position y on the y-axis, one moves a distance a further than the other, right? Well, distance a is a whole lot of wavelengths. Okay? So let's say it's 738 wavelengths, right? Then they'd be in phase. If it's 738 and a half, then they're going to be half a wavelength out of phase, right? Okay? That'd be like 180 degrees or pi radians out of phase, right? The relative phase would then be 180 degrees or pi, depending which system of measurement you would use. And you do use both, okay? When you're doing it mathematically, you're going to use multiples of pi. But if you're thinking about relative phase, you might well think of it in terms of degrees. It's just easier to visualize. Okay. So the relative phase is the number of wavelengths of difference, okay, neglecting whole wavelengths. Because every time you change by a whole wavelength, your phases return to zero, right? Relative phases. Whole wavelengths make no difference.
So does that mean that the y-axis is zero then also? The
Y could be anything. Okay? If the difference here is a whole number of wavelengths,
right,
then there'll be the relative phase zero, but you know, Y could be any number. So it could be anything, right? So what we do is okay, I'm going to write this out in mathematical form. The meaning is fairly easy. It's going to be A over lambda, which is the number of wavelengths, right? Including fractions. Okay? Minus INT standing for integer of A over lambda. There are other notations, but I'm going to use this. The greatest integer in A over lambda. Okay? Which means if there are 738.76 wavelengths, then the greatest integer in A over lambda would be 738. You'd subtract that from the 738.76 and have 0.76 wavelengths, right? So that's actually how you would calculate it. If you're programming, you have a greatest integer function, which is actually usually called the floor function, but you know, we're not going to worry about that. That's simple. It's simple to figure out how to get the greatest integer, okay? Make sense? You just round the number down to the nearest integer, and then subtract that off, and you're left with the fractional part of a wavelength that determines the phase difference, okay? And so the phase difference is this difference times the 360 degrees in a complete phase, right? Or times 2 pi if you want the difference in radians, depending on whether you're wanting to think about what it means or calculate with what it is, okay? If you're going to calculate things, you're going to want to use radians, so you don't have to carry along conversion factors for degrees, okay? But if you want to think about the phase in a 360-degree circle, you know, that's more convenient.